Hey, hello everyone. My name is Rayhan. I'm a student of PTIKA, and in this meeting, I'll be teaching about one of the most important basics in programming. We're gonna talk about decision making in C++. Today, we're going to talk about how programs make decisions using if else if, and switch. By the end of the lessons, you'll understand how a program chooses different actions depending on the situation. So, let's get started. For example, if the user enters a correct password, allow login. If a student's score is above 75, they pass. If the weather is hot, display a message telling the user to drink water. Decision making allows a program to choose its behavior based on specific condition. In today's lesson, we will cover everything including what is condition, relational and logical operators, the if statement, the if else statement, the else if chain statement, the switch case structure, and finally a mini project where we apply all of these concepts together. Pay close attention because understanding decision making is the foundation for loops, algorithms, form validation, logging system, calculators, and many more programs that you will build later. Okay? Now, as you can see, there's four branches of understanding decision making. The first one is if statement. The second one is if else statement, else if statement, and switch case. Decision making in programming means the program checks whether a condition is true or false, then decide what to do next. You can imagine it like this: if something is true, go to path A. If it's not true, go to path B. A simple life example: if it's raining, I use an umbrella, else I don't. Computers operate exactly the same way. To create conditions, we use operators. Okay. Uh, Now take a look at this. Relational operators. They are used to compare values. When the operators look like this, it means greater than. Example, if the x greater than 17, as the explanation, true if x is more than 17. And the second operator is less than. If you see in the operator like this, it means less than. If the score less than 50, true if the score is below 50. Greater or equal. If height greater or equal than 150 is true. True if height is 150 or more. Less or equal speed. If the speed less or equal than 60, it means true if speed is 60 or less. Equal to. True if x is exactly 10. Not equal. True if number is not 0. Condition built with these operators always written true or false. Next, we're going to talk about logical operators and or not. Sometimes one condition is not enough. We combine them. The first one is and. You can see, and logo is has a look like this. But condition must be true. But condition must be true. Example: true only if X is 17 or older and the citizen is Indonesian. You can take a look about the example code like this. CPP. If X more than equal 17, then citizen is Indonesian. Second one is or. True if at least one condition is true. You can look at the example of code. If value is 10 or a value is 20. Not reverse the condition, meaning if it's not raining. The sample is code like this. Okay, now we're going to talk about if statement, one way decision. You can take a look about the example code here. Okay, now we're gonna explain the code line by line. Integer x equal 18 is has a meaning creates a variable called x. Value is 18. This is the data we want to check. If x more than equal 17, this is the condition it asks: is x 17 or above? The expression can only return true or false. Start of the code block runs only if the condition is true. Couch, you're an adult. This will be displayed only if the condition is true. So, if the condition is true based on the code, there will be an output like you're an adult. And of the if block, why use if? Use this when you want the program to do something only under one specific condition. So you can use if you wanna make only one specific condition. And then next, if else statement, two-way decision. There's some example code that you can take a look about if else statement. We're gonna explain it line by line. Enter score 60 creates a variable named score. If score more than equals 75, check if the student pass. Count pass. Displays if score is 75 or above. Else, else activates only when the if condition is false. Count fail. So if there's another condition between the another condition that you input right here, if the score more than equals 75 is called pass, and another condition, or that we can say else, there will be code as fail. Displays if the score is below 75. Why use if else? Use it when there are two possible outcomes. One is true, the other must be false. The other must be false. Sorry. Wait. And then we're gonna talk about else if multi-condition chain decision. You can take a look for the example of code here, and then we're gonna explain the line by line code. If score more than equal 85, check for grade A first. Check for grade A first. Else if score more than equal 75, only check if the previous if was false. Else if score more than equal 65, only check if both previous conditions are false. Else default for all others. Important concept. Program checks from the top to bottom. Stop when it finds the first two conditions. Other methods. Okay. Uh, it's similar like if else, but it has some complicated condition. It's more than complex than if else, but overall they kinda look similar. The last one is switch case, fixed menu selection. As you can see, there's some example of the code of switch case. Line by line explanation of this code is switch is a menu. Switch choose based on the value inside parentheses. Case 1, if menu equal 1, run this block. Count, profile menu. What display? Break, stop switch from continuing to other case. Default, runs when no case match, same idea as else. Why you switch? For clear menu choice 1, 2, 3. Easier to read than many if else if statement. Okay. Then testing, debugging, and logic verification. Testing strategies: partition testing, identify input regions, equivalent classes, and test one case from each class. Boundary testing, test values at the boundaries, values exactly on the limits of range. Decision table testing, create a table of condition combination and expected actions. Test all relevant rows. Path coverage, at a more advanced level, aim to cover all main execution paths, true or false for each branch. Debugging tips, add clear logic at important branches so the execution path can be traced. Avoid side effect inside condition. If they exist, separate them so that debugging can inspect input values without change state. Unit test predicate functions, functions that only return true or false separately from the action they control. There is some quiz and exercise for you guys. There's an essay question that there's essay coding text multi-condition decision. So you must write a C++ program that asks the user to input their age and membership status. The program must decide ticket price using the rules below, as you can see. If the age less than 5, it's called free. And then if the age in the range or of 5 to 17, it called 20,000. If the age is about 18 to 59, it's called 35,000. Else, if the age more than equal 60, it's called 25,000. If the user is a member, give an additional 10% discount from the final price. Your answer your answer must include the complete C++ program, explanation of each decision structure you use, why the order of condition matters in this program. Okay, thank you very much for pretending to stay in my class. Uh, Sekian dari saya. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih.